Greetings, math fans. All right, so today we're going to talk about the power theorem. So much power. Sorry. Okay, so this is the power theorem. And actually, it's the power theorem, but it's also created or developed by a person called, his name was Demov. Okay, so it's Demov's theorem. He's a French guy. See, otherwise you'd say Demovres, and then you wouldn't sound French. So you have to say Demov, and you say it in a French voice, and that's very friendly. Okay. Anyway, the power theorem is this: if I have r times cosine theta plus I sine theta, and it's raised to the nth power. Okay, that's really what we're going to think about. Now, I'm not going to go through a complete development of this, but I want you guys to understand a little bit where it comes from. Okay, we're going to actually think about the product theorem that we did our last class here. So just think about it. If I have R1 cis theta 1 times R1 cis theta 1, don't you guys agree that that really is the same thing as saying R1 cis theta 1 squared, right? So if I actually apply the product theorem to this guy right here, I would get R1 times R1, which is R1 squared, cis, and what do you do with those angles? You add them. So it's theta 1 plus theta 1, isn't that 2 theta 1? Okay, so that's kind of interesting. That's it squared. Let's do it cubed, which would be R1 cis theta 1 times R1 cis theta 1 times R1 cis theta 1. Okay, so what's that going to be? Well, that's going to be R1 cubed cis, and there are three of those, theta 1 plus theta 1 plus theta 1, so it's 3 theta 1. So now let's go back to this original equation here, okay, or formula. It's R, or I should say expression, so it's R cis theta to the nth power. So what do? Well, it looks like what I do is I actually raise that to that power. You guys agree with that? So that is raised to whatever that number is. How many times I'm doing that? So that's your n. And then that's your n also. So here's your n. So I can now write this as that's equal to, again, Demov's theorem, r to the n cis n theta. That's it. That's Demov's theorem. Okay, so I want you guys to understand, you raise this to the power. Kind of like when I did multiplication, I multiplied it. When I did division, I divided the r's. When I raised it to a power, I also raised the r to the power. But what I do with this is important, is here you multiply that power times theta. Okay, as opposed to multiplication, what did I do? I added the thetas together, theta 1 plus theta 2. Or division, I subtracted theta 1 minus theta 2. Okay, here you're going to multiply. All right, so that's kind of what Demov's theorem is all about. Let's do an example. If I gave you 2 root 2 minus 2I root 2, and I said raise that to the 6th power, and I asked you guys to do that by hand, which is something you guys can all do, right? You basically have to write out 2 root 2 minus 2I root 2 6 times. You got to FOIL it, then you got to distribute again. And if I gave you a problem like this, you guys would cry because you would say it's way too much work, and it would just be really a sad time. Okay, so what we're going to do is we're going to actually use Demov's theorem to simplify that an exponent. Now this is key here. Okay, I'm going to draw a key. Okay, the key to Demov's theorem is, before you use it, the expression must be in polar form. This is so huge. It's got to be in polar form to use Demov's theorem. Okay, because you need, right, everything's in terms of thetas, and we don't have thetas here. We just have a rectangular expression, right? So you got to convert it all into polar form. Well, it's pretty easy. Okay, what we're going to do is, of course, we're going to draw it down to the fourth quadrant here because we have a positive real value and a negative imaginary value. So this is going to be 2 root 2 here, and this is going to be 2 root 2 here. And if you guys know, right, this is a 45, 45, 90 triangle, right? And so that's x root 2, right? This, just to kind of refresh your brain a little bit with our right triangles. This is x, and x root 2. So you would say, oh, x equals 2 root 2. So then I say, well, what's x root 2? That's just saying 2 root 2 times root 2, which is 4. Okay, so that's really what I need here. I need that 4, and then of course we know our angle here, it's 45 degrees, but I need this angle around here. Don't forget that. Okay, so that's going to be 315 degrees. So I know my theta is 315, and my r is 4. Okay, now I can put it in polar form really easily. It's just going to be 4 cis 315 degrees. And again, that's raised to the 6th power. All right. Now I can apply de Moivre's theorem. Well, that's really easy. It's just saying 4 to the 6th cis 6 times 315 degrees. So 4 to the 6th is 4,096. Cis 1890. That was a good year. Okay. Now, this is really important, math fans. You can't. Please don't leave it like that. If I ask you for it in polar, you cannot leave it like that. Theta has to be between 0 and 360. It's always got to be that. Nothing bigger than 360 or less than 0. Very important. Okay. It can equal 0, of course. All right. So I'm just going to do coterminal. So 4,096. Oops. Cis. And I'm going to subtract 360 from that 5 times, and I wind up getting cis 90. Beautiful answer. So that's an answer in polar form. Now, if I ask you an answer in rectangular form, of course, you would just, it's always helpful to write it out as cosine 90 degrees plus I sine of 90. And then you get 4,096, and cosine of 90 is 0. Sine of 90 is 1, so it's I. So my answer is 4,096i. Ooh, that's a lot of i's. Okay, it's a very scary monster. So that's using de Moivre's theorem. Again, I have it in polar form, and I also have it in rectangular. And I'll be very specific with what I want on a quiz or test. All right, so just kind of watch what I'm asking for. But that's pretty easy. Now, one quick thing I want to mention here, math fans, is I did use 315 degrees. Now, if you notice going back to this guy right here, I could have said negative 45 degrees. That's not, I can't use it for a final answer, but sometimes it's easier to multiply 6 times negative 45, okay, and, you know, that would maybe make the numbers a little bit smaller. It doesn't really matter, but as long as your final answer is within between 0 and 360, you're good to go, okay? All right, so let's do a nice friendly problem. That's actually pretty easy, but I want to show you how this all works. So if I said 1 plus I quantity squared, well, I'm going to use de Moivre's theorem real quickly. Okay, I'm over here in this first quadrant, so this is 1 and 1, and this is root 2. Okay, and then of course it's a 45-degree angle here, and that is actually what theta is. And then, so let's write it as root 2 cis 45 degrees squared. Okay, so it's root 2 squared. Cis, and I'll show my work here, 2 times 45. So it's root 2 squared is 2. Cis 90. Okay, so that's, again, that's the answer in polar. Most of the time, if you can actually have a 30 or 45 or 60 degree reference angle, I'm going to ask you probably to simplify it to rectangular. If it's some odd angle, I'm not going to ask you guys to simplify that. All right, so anyway, we get 2 cosine 90 degrees plus I sine of 90. And that's 2, and then cosine of 90 is 0 plus I, so you get 2i, like a normal human being, 2 i's. All right, now that's using de Moivre's theorem. Let's just use it the old-fashioned way. 1 plus I squared is 1 plus I times 1 plus I. So I get 1, if I do FOIL, 1 plus I plus I plus I squared. So we have 1 plus 2I. I squared is negative 1. Ooh, very exciting. They cancel out and we have 2I. So we have the exact same answer here. Okay. Now, which one would you use? Probably you'd use this guy right here. Okay, if I asked you guys to do something squared. But again, if I use something to the third power, to the fourth or fifth, something brutal, I would expect you guys to use de Moivre's theorem. Okay, otherwise it's going to take you forever, and you'll complain, and everyone will drop, and I'll have a cricket in the corner chirping, and nobody else will be here. Okay. Anyway, let's talk about roots of a complex number. Okay, this is the farmer's favorite topic, roots. I'm just kidding. Okay. First of all, let me give you a problem here. X cubed equals 8. And what would you give me for an answer for this? If I said x cubed equals 8, well, wouldn't you take the cube root of it and the cube root of that? Wouldn't you just tell me x is equal to 2? Because the cube root of 8 is 2. Okay, everybody agree with that? Yes? Okay, lock in your answer. Push this button to lock in your answer. Okay, well, actually, it's wrong. So you'd lose. All of the money would drop if you're playing that $1 million drop. I'm making this video in, actually, it's Christmas Eve, 2010. Okay, but it's in the morning, like 1 in the morning. I don't know, I'm just making a video early in the morning. Anyway, it is not correct just to say x equals 2. Because technically, let's look at this. If I said x equals 4, how many answers do I have? Well, I have one answer, of course. X equals 4. What if I said x squared equals 4? How many answers do I have? I have 2 answers. Don't I have, take the square root, I get plus or minus 2. Okay, and so what does x cubed equals 8 should give me? Well, I really should have 3 answers. And x to the 4th equals something, and x to the 5th, right? This is 4 answers and 5 answers. So really, whatever the exponent is, that's how many your answers you're going to have. All right. So let's do this problem now. It's x cubed equals 8. Let's rewrite it as x cubed minus 8 equals 0. So do you guys remember this is a difference of 2 cubes? So I can write this as x minus 2. And then it's x squared. So it's the square root of that. And then it's, I don't know if you guys remember learning it this way. I learned it from some summer school kids as difference of 2 cubes or sum of 2 cubes is SOAP. And you're like, what does SOAP have to do with this? Okay, well, SOAP stands for same sign, opposite sign, always positive. So we have same sign as this, opposite sign, so it's minus, and then it's you multiply these together, right? It's the cube root of x cubed is x, cube root of 8 is 2, so it's 2x, and then always positive, so this is plus here, and then that's squared, so 2 squared is 4, and that's what that factors to. Okay, hopefully you guys remember that. Oh, I said opposite sign, so I need to do that. All right, so same sign, opposite sign, always positive. There you go. All right. So if I set that equal to 0, don't I get x equals 2? Well, that's the answer you guys gave me originally. And the other one, you can't really factor that one, so you got to use the quadratic formula. So x equals opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times 1. Okay, so x equals negative 2 plus or minus the square root of 4 minus 16, which is negative 12, over 2. And that's equal to negative 2 plus or minus, you can factor out well, you got to factor out an I and a 4. So you get 2I root 3 over 2. And then, of course, you simplify it to separate the real from the imaginary part. And we get negative 1 plus or minus I root 3. All right? Negative 1 plus or minus I root 3. Very exciting. Now, let us use de Moivre's theorem. Okay, so let's write this. I'm going to write this in the corner here. So our answer that we just got, we got x equals 2 and x equals negative 1 plus or minus I root 3. That's what we got from factoring. Okay, so this is kind of the big deal here now with de Moivre's theorem. Okay, we get x cubed equals 8. And the first thing we're going to do is we're going to solve for x. So we get x, and I'm not going to actually take the cube root of that. I'm just going to write it as x equals 8 to the 1/3 power. Okay, then I'm going to do is I'm going to write in polar form. And so remember, in polar form, 8's over here. So isn't r equal to 8? And isn't theta is equal to 0 degrees? Sounds good to me. So I'm going to write x equals 8 cis 0 degrees to the 1/3 power. Okay? And then what we're going to do is apply de Moivre's theorem. And remember, de Moivre's theorem is you say 8 to the 1/3 power, you raise that to the power, and then it's cis 1/3 times 0. Right? You multiply that times that power times the angle. So this is our first answer. And because we're going to have three answers here. So 8 to the 1/3, of course, is 2 cis 0 degrees. And of course, this is polar. I'm going to ask you guys to convert that to rectangular. So it's equal to 2 times cosine of 0 degrees plus I sine of 0 degrees. So it's 2 times cosine of 0 is 1 plus 0i. So my answer is 2. Okay, and there's our first answer, math fans, right here. X equals 2. All right, so let's work on the next one. Now this is the deal. We know there are three answers. Okay, and they're going to be equally spaced. If we talk about the unit circle, they're going to be equally spaced going around the unit circle. All right, especially in polar. And there's 360 degrees in a unit circle, right, going around, and so we're going to divide it by 3. All right, so our spacing or our increment is equal to 360, always 360 divided by, this is the number of answers. So it's equal to 120 degrees. So what I'm going to do, this is really important, is for my second answer, I am going to take this right here, this 2 cis 0 degrees, okay, and I'm going to add to the 0 degrees, I'm going to add 120 degrees. So that's what you're going to do with that spacing. You're always going to add that to the first answer, and then you're going to add 120 to the next answer, etc., until we have three answers. So you're going to say 2 cis 120. That's actually our second answer. That's in polar form. In rectangular form, it's 2 times cosine of 120 plus I sine of 120. Okay, and you just figure that out, right? Our reference angle for this one, well, first of all, over here. So cosine's negative, sine's positive. Reference angle is all back to the old days, 60 degrees. And so you're going to say 2 and cosine of 60 is 1/2, so it's negative 1/2. And plus, right? Plus I root 3 over 2. So if I multiply that out, I get negative 1 plus I root 3. So that is our second answer. Hey, look at that. Right there, math fans. There's one of our answers. Let's do the third answer. We're running out of room here. The third one is adding 120 degrees to that. It's 2 cis 240. So that's, again, polar. So rectangular is going to be 2 times cosine of 240 plus I sine of 240. Okay, we're over here. Sine and cosine are both negative. So I'm going to write equals 2, same reference angle. It's kind of nice. Still 60 degrees. So it's still going to be negative 1/2. But this is going to be negative I root 3 over 2. And I multiply that out. And hopefully you guys can see it. I'm going to move this down a little bit. You get negative 1 minus I root 3, which again, there's the other part right there. Okay, so those are your three answers: 2, negative 1 plus I root 3, and negative 1 minus I root 3. And that's how you use DeMoivre's theorem to find out those three different answers. Okay, which again gave you the same answer as difference of two cubes, but I guess the deal is what happens if I give you something nastier. Okay, so let's do that. That's actually going to be kind of quick here. If I gave you x to the fifth equals negative 1. Okay, well that's actually kind of brutal. You know there are 5 answers. All right, and isn't one of your answers negative 1? Right? If I took the fifth root of negative 1, it's going to be negative 1. Because negative 1 times negative 1 all 5 times gives you negative 1. So I know one answer is negative 1. But that's not all your answers. You have 5 answers total. So this is the deal. We're going to write this as x to the fifth equals negative 1 to the 1/5 power. Please make sure you take the right root here. Okay? And we know that negative 1 is over here. So isn't r equal to 1 and isn't theta equal to 180 degrees? All right, so there's my setup. This is supposed to be just x is equal to that, right? I took the fifth root of that also. Okay, so we get our first answer in polar form is going to be, first of all, well, actually, let's write it in polar form. It's going to be 1 cis 180. Okay, and so it's going to be 1 cis 180 to the 1/5 power. Well, what's 1 to the 1/5 power? 1. So here's my first answer now. So it's 1 cis 180 times 1/5. Remember, it's times 1/5 is 36 degrees. Well, again, I won't make you put that into rectangular because I don't know what the cosine and sine of 36 degrees is. Okay, it's not an exact answer. That's my first answer. The second one, okay, I'm going to be adding, because there are 5 answers, 360 over 5. And that's 72 degrees. So that's my first. So my second answer is 1 cis, and I add 72 to that, and I get 108. And my third answer is going to be 1 cis, I add 72 to that, I get 180. Now the interesting thing about this one is, let's actually look at this one, because I can do this one. 1 times cosine 180 plus I sine of 180. And cosine 180 is negative 1. So it's 1 times negative 1. Sine of 180 is 0. So what do we get? Negative 1. Ooh, look at that. Okay, got one of our answers right there. So fourth answer is 1 cis, again, add 72 to that. I get 252 degrees. And the fifth answer is 1 cis 324 degrees. Notice all these answers are between 0 and 360, which is good. Let's say I start out with 108 for some odd reason, and you went up and this went above 360 for my fifth answer. Just make sure you do coterminal to bring it back to something between 0 and 360. Okay? But again, I would not, this type of problem, I'd probably just ask you to give me all the answers in polar form, because, again, I don't know what the sine and cosine of 324 degrees are, or is, so we wouldn't have to worry about it. Okay, let's keep going here. Another type of problem. Another type of problem I can ask you is this. Find all cube roots of 27i. So this is the deal. I said find all cube roots. I am finding 3. I'm going to get 3 answers here. So really what you want to do is you want to set up the problem like this, math fans. X cubed equals 27i. That's how you set it up. Now, before I gave it to you, I said, oh, hey, solve. I said x cubed equals, 8, and solve, and then you get 3 answers. This one I'm going to say, hey, find all cube roots of 27i. So you set it up this way. X cubed equals 27i. All right? So, of course, we need to write it in polar, as we always do. So it's going to be 27i is up here. So r equals 27. Theta is 90. Okay, that's pretty easy. So we're going to say x is equal to 27 cis 90, and that's to the 1/3 power. All right, then we're going to apply de Moivre's theorem. That's easy. It's 27 to the 1/3 is 3, so this is my first answer. So it's 3 cis, and it's 90 times 1/3, which is 30 degrees. Okay. Now again, that's polar. Probably a good idea to do rectangular if I asked you for it, because it's pretty easy to do that. So let's do that. It's 30 times cosine of 30 plus I sine of 30, which is equal to 3. Cosine of 30 is root 3 over 2. Sine of 30 is 1/2, so plus I over 2. So we wind up getting 3 root 2 over 2 plus 3I over 2. Okay, that's one answer. Pretty reasonable. Second answer is 3 cis. Remember, there are 3 answers, so it's 360 over 3, which is 120. That's what I'm going to add. So it's 3 cis, and I add 120 to that, I get 150. So 3 times cosine of 150 plus I sine of 150, and that's equal to 3. Of course, we're in this quadrant now, so it's negative. Same reference angle, right? So negative root 3 over 2 plus I over 2. So we get negative 3 root 3 over 2 plus 3I over 2. Okay, so there's another answer. And then the third answer is going to be 3 cis, and at 120 of that we get 270. Okay, and again that's our polar answer, and a rectangular is going to give us 3 times cosine 270 plus I sine of 270, and cosine of 270 is 0. Sine of 270 is negative 1, so it's minus I, so we get negative 3I. And those in the boxes are your answers in rectangular form. Okay, those are 3 answers. That is not too bad. Okay, I have one last example here, and it's going to look like a really evil, nasty example, but it's actually really not that bad. This is actually number 42 in the book. So it's x to the 4th minus parentheses 8 plus 8I root 3 equals 0. Now, if I gave this to you yesterday or at the beginning of the year, again, everybody would drop because it looks really scary, but it's actually a really easy problem. First thing I'm going to do is I'm going to solve for x. So x to the 4th equals 8 plus 8I root 3. And then there are, of course, 4 answers. Very important. And I'm just going to rewrite this in polar form. So we're over here. And so this is 8 here, and this is 8 root 3. Well, I definitely recognize this is a 30, 60, 90. This is 60 degrees here because people born in the 60s are radical. And then this is going to be 16 right here. All right. So if I write that, it's x to the 4th equals 16 cis 60 degrees. Pretty easy. And then I have x equals 16 cis 60 degrees to the 1/4 power. Okay, let's apply de Moivre's theorem. Get our first answer. 16 to the 1/4 is 2 cis 15 degrees. Remember, you multiply 60 times 1/4. That, again, I'm not going to ask you for rectangular because that's kind of nasty, though you could be able to do this using half angle or using difference of 2 angles, right? I could do 60 minus 45, right? Okay, but I won't. Second answer is going to be 2 cis, and remember you're adding to that 15-degree angle. You're adding. Oh, we got to do this here. 360 over 4, which is 90 degrees. That's our spacing. So it's going to be hey, my favorite number, 105. And the third answer is going to be 2 cis 195. And our fourth answer is going to be 2 cis 285. Okay, so remember, if any one of these answers, like this guy was greater than 360, you just do coterminal and bring it back to something more normal. Okay, but all these answers always have to be, I'm just going to stress it again, they have to be between 0 and 360. Including 0, not including 360. Okay, so real quickly, let me summarize this because I don't want to take too much time here. If you have a problem, so summary. If you have x to the fourth equals something, or if I say find the fourth roots, okay, you're going to have 4 answers. Please remember that. Okay, that's the first case, so we'll call that case A. Case B is literally if I said, hey, root 2 plus I root 2 to the 4th power. That's a single value, so this is one answer. All right, it's like saying what's 2 cubed? It's 8. It's not 3. There are 3 answers for that. 2 cubed is 8. Okay, but if I said x cubed equals 8, now I've got 3 answers. So be aware of that, what I'm asking for, math fans, and then you'll be good to go. All right? Anyway, that's it. You have an awesome day, and Merry Christmas, because it is Christmas Eve. Adios. Goodbye.